Let's now look at without row ID tables. By default, a row ID column is added to every table as a primary key. Whether or not you define your own primary key, if you have a column of type integer primary key, then that column name is treated as an alias for row ID. Let's see what that means. So if you look here, there's a table called scores where you have a name, text and a primary key, and there is a score of type integer field. This is what the schema of the table is. However, if you notice this select statement here, row ID name score from scores, you'll see that each row has a row ID. Although you mentioned name as a primary key and that itself could have been used for indexing, there is also another field called row ID that's being implicitly created and managed. As you might notice here, as part of our inserts, we never gave the row ID. The SQLite engine behind the scenes assigned a row ID which is unique across the table for each insert. As you can observe, the row ID column is going to occupy additional space. In case you don't want that behavior, as in your device is super memory constrained and you want to suck the last bit of performance out of it, then you can specify the phrase without row ID at the end. So here is a word count example showing you the same. Here you have word, which is a text and a primary key, and then you have a count, which is an integer. Let's just go ahead and paste this definition. And let's just select the row ID to see if it even exists, right? Row ID from word count. There is no such column. So that's how you do it. Let's now see from an indexing perspective as to how without row ID phrase gives you an advantage. So here's the first type of table creation wherein you don't have the without row ID phrase at the end. So what happens internally is two B trees are constructed. There is one where the key is a row ID and the value is the entire row, the word and the count. And since word is mentioned as a primary key, an additional index is maintained where the key is a word and the value is a row ID. So whenever you search by word, two searches actually take place. So the first one makes use of the second B tree to locate the row ID from the word, and then it goes inside the first B tree to get the count if you request for the count. Whereas in the case of without row ID, there is just one B tree that's constructed. Since word is mentioned as the primary key, the key is the word and the value is the rest of the row. In our case, it's just the count column. So the search is now restricted to just one in case you request for a count. That's the advantage of without row ID. Hopefully this point makes sense now. That is, a primary key is optional for ordinary tables, but it is required for without row ID tables. Why is it required? If you didn't have a required primary key column, then there is no way to construct a sane B tree here. Here are some gotchas associated with a without row ID table. As we saw before, the table must explicitly define a primary key. Auto increment does not work on without row ID tables. What does auto increment mean? So we just saw in the row ID assignment here that increasing numbers were provided. So this is an example of auto increment. So if the value isn't provided, or if the value provided is null, then the SQLite engine takes care of assigning the next number that is greater than the maximum number seen so far. That is auto increment. Then the last thing is not null is enforced on every column of the primary key in a without row ID table. What does this mean? In case we have just one column as a primary key in a without row ID table, then that column has to be not null. That is, that column shouldn't be null. If we have a composite primary key, so if we have something like this, right, then the ID cannot be null and the name also cannot be null. Now that we have seen a bunch of details about without row IDs, why not just use row IDs all the time, right? Clearly, if we can take care of our primary key constraint, we can just throw in without row ID all the time and get the advantage of getting rid of the row ID column. Turns out there are a bunch of scenarios when you might not want to use without row ID. Let's see what they are. For starters, avoid creating without row ID tables with single column primary key of type integer. You're basically mimicking a primary key. That is, whether or not you have without row ID is not going to make any difference here, so it's useless for you to do this. It is likely to be helpful for tables that have non-integer or composite primary keys, especially when you're not going to store huge rows of strings or blobs. That is, your row length is also small. Without row ID tables work best when individual rows are small. That's because they're implemented as ordinary B trees and the content is stored on both leaves and intermediate nodes. Since data is floating around in both the leaves and non-leaves, you want to keep the rows as small as possible. So it turns out there is actually a bit of math here to be observed. So by default, the page size is 4 KB. If your row is of 1/20th the size of a database page or lesser, then you can afford to use without row ID. So that basically the row size should be less than 0.2 KB. So there is also one more thing to observe here. In the case of row ID columns, row ID tables basically, content is stored in just the leaves of the tree. So you can insert arbitrarily large rows. Whereas in the case of without row ID tables, content is stored in both the leaves and intermediate nodes. So this is again something to bear in mind. So that's about it as far as without row IDs are concerned. Let's now do a couple of exercises to check what we've understood.